Right, so revision stream. Yes, we are about 3 weeks away from exams now. We have a 1 week holiday, 1 week back to school, and then exam week, which is brilliant because um yeah, exams. Obviously these ones are mock exams, but they'll be kind of like exams. We get a grade at the end of them. So we need to take these seriously, and as a result of that, I'm gonna be revising today, tomorrow, and basically every day of the holidays. I'm gonna be attempting to revise just for a little bit. Maybe only half an hour per day, but what that means is that I can remember some stuff and hopefully, use it in the exams. So what we'll be doing today is biology. What I have here is a sheet of bullet point notes for every topic. All it is it tells me what the topic is, and then from there, that's where I go. So, biological molecules, that's the first topic that we'll do. Now, what I need to do, actually, is I need to screenshot this when I get it done, because what's happening now is the teachers are actually starting to ask us for proof of revision. And because I do all my streams, I can't just send them a link to a stream. That would be really wrong. I'm sure the teachers don't want to spend hours watching my streams, and I don't think they legally can. So instead, if I just send them a screenshot of what I've done, that should count, I hope. So, biological molecules. We're going to start off with carbohydrates, lipids, and on this side, we'll do nucleic acids and proteins. Now, yes, I am aware that there are things like ATP, water, and inorganic ions. We'll do them all in a little. Let's just focus on a couple at a time. And I think to start off with, we will do... Let's start off with proteins, actually. This topic is still fresh in my mind, I think. So you have an amino acid, which, from what I can recall, this is going to be my best guess because I don't recall. It's an amine, so it's N H H and then C N the R group, and then C O. I think that might be it. I don't recall what the structure of an amino acid is. Let me Google that quickly so I can recall. Okay, I got that bit right. It's 2 hydrogen, nitrogen. It's double O. Oh, it's C. Okay, hold on. C O and then H. Okay. Oh, because it's a carboxyl. COOH. Okay. Why didn't I remember that? And the side chain, which is that. Okay, so that's an amino acid. That is the amino acid. And from that, you have your primary structure, which is just a sequence or a chain of amino acids joined together. And then from there you have your alpha helix or beta pleated sheet. And that's when hydrogen bonds begin to form at the ends. From there, it becomes a 3D polypeptide. One sec. I'm back. Okay. So that was the 3D polypeptide of a tertiary structure. That's when ionic bonds begin to form between the positive and negative charges, which might not seem like an important point to get down, but it is, because you might get questions on the positive and negative charges. You get your disulfide bridges, and those are specifically between the cysteine amino acid and the hydrogen bonds, which form throughout the structure. The ionic bonds, we can quickly talk about that. pH will affect these. Very easily break apart the bonds. Disulfide bridges, I don't recall what it was, but there was something in an exam question about them giving structure, or they are the things that actually allow the polypeptide to be a 3D structure. So I'm just going to Google that. Disulfide bridges, they are an important component of the secondary and tertiary. Okay, let's have a look. So from what I can understand here, they are the things that actually cause protein folding. Okay, that might be an important part to put down then, folding. And I guess that's why when an enzyme is denatured, that's because the disulfide bridges are broken, which changes its structure. That's interesting then. And then the quaternary structure is just multiple different polypeptide chains joined together. So, that right there is proteins, but we should probably talk about enzymes too, because enzymes are important. there is the main model which we are beginning to use is the induced fit model. And then from there, I'm going to go add some little bullet points. So that's the active site. That will obviously be the substrate. That is complementary. And it forms an ES complex. Those are the most important keywords to get down: complementary and ES complex. I mean, you could talk about inhibition too. There are two different types of enzyme inhibitors: competitive and non-competitive. Competitive inhibition is where it has a similar shape. This inhibitor has a similar shape to the active site, so it binds together, but it does not form an enzyme substrate complex, and thus prevents future and further enzyme substrate complexes being formed. And the non-competitive bind to the inhibition site of an enzyme, which causes the enzyme substrate complex it causes the active site to change shape, so no more ES complexes can be formed. Which is interesting, actually. It's kind of cool how that works. So, we've done proteins, we'll do lipids next. You got your triglycerides, first and foremost, which is your glycerol and your fatty acids. Now, an important thing to remember is that in terms of glycerol, glycerol is going to be hydrophilic, and the tails are going to be hydrophobic. I believe, anyways. Maybe don't quote me on that. We do a lot more on, what's it called? Phospholipids. That's the one we do more on. I believe this is kind of a structure here. Phospholipid. You got your phosphate group, your glycerol. You got your polar and non-polar. Now, oh no, I'm so sorry. No, that is not what I meant to say. You have one which is saturated and one which is non-saturated. And these are your fatty acids. Now, let's quickly talk about lipids. I'll just kind of... the interesting thing to note about lipids is you have your saturated and unsaturated. So this would be unsaturated. That would be saturated. From there, I mean, is that really... That's kind of everything to talk about for lipids. I guess we could quickly refer to a phospholipid bilayer, which is obviously an important part of the topic. This would be... phospholipid bilayer. Those would be the extracellular liquid, I guess. And that would be the obviously inside. Phospholipid bilayer. What else can we talk about? I guess we can talk about hydrolysis and condensation, which is a very vital part of the topic. Hydrolysis is where... So condensation basically uses... So if this has a H and this has an OH, and then this is a H2O, then what ends up happening is it's removed or added. So if you wanted to join together a... I'm accidentally destroying half of the work here. If you wanted to join together two amino acids, you would get rid of the hydrogen there, get rid of the OH there, and you would join them together, like so. Kind of cool. So... I guess we could quickly refer to carbohydrates, which are, of course, used in respiration, or glucoses. So you have your alpha and beta. You got your beta glucose and alpha. Now, you got your alpha B, that is cellular, that is glycogen, I believe. Forgot the name. And starch. Starch is kind of like this, glycogen is like this, and cellulose is like that. You got amylose and amylopectin. Amylose is that, amylopectin is that. Glycerol highly branched for enzymes to hydrolyze the bonds to allow for easier energy release. Storage molecules. Now, an interesting thing I probably should point out is the tests. For this one, you have your Benedict's, and that's for reducing, or hydrolyze, neutralize, and then add Benedict's, and that's for non-reducing. And I guess you should say you should heat. So neutralize with heat, hydrolyze, etc. Ow, I just chipped my toe. Lovely. Nucleic acids. You have... Okay, now this one's really going to test my memory. Your base, your penta sugar. I think that might be it. For a test on lipids, you would use emulsion. So, your emulsion test, which I'm going to quickly Google. Take liquid sample and add ethanol. That's it. That's the one. Liquid. Liquid sample plus ethanol, and it's the presence of an emulsion. White emulsion. And then finally, the other test is a protein test, which is the bio. This one is easy, it's just purple proteins. Basically, that's it. You just add it to a thing and heat. I'm gonna... That is basically it. I'm just gonna Google nucleic acids because I need to recall the structure of one of these. Ah, it's the phosphate, the pentose sugar, and the base. So I was right. So it's the phosphate, the pentose sugar, and the base. And there's the AUCG. So you go in DNA and RNA. You got your phosphodiester bonds. Which would be there. And then that is basically the whole topic right there. That is, if I move it back a little, you guys might be able to see. That is basically it. I'm too dumb for this, bro. Me too, man. Me too. That is basically it. I mean, I did kind of miss out a handful of stuff for nucleic acids because I'll be honest, this topic gives me a headache. I guess you could talk about double helix. I don't know. That being a single strand, a smaller strand. I don't know, honestly. I don't know. I feel like that's as much as I can fit on this whiteboard without it looking like some Philip Carvel-esque drawings. I feel like I've missed some stuff. I have. I've missed a lot of stuff. You got your glucose plus glucose and galactose, and glucose and fructose. Glucose and glucose is maltose, I think. Glucose and galactose is lactose. and glucose and fructose is sucrose. I want to say that that's... Hello, I'm back. Okay, apologies, I am back. So, where were we at? I forgot. I feel like this is most of it. I feel like this is most of the topic. If you guys kind of take a step back, you do this for work or for school. This is school stuff. This is we have an exam coming up in about 3 weeks. We're on the school holidays now for a week, but our teachers have given us an obnoxious amount of homework and stuff to do. So as a result of that, I'm trying to make the most of time to revise. And that was only one topic. That's not even a joke. That was one topic. We have... hold on. Let me just go through everything quickly. We've done... we haven't technically done monomers and polymers, but that's kind of obvious. Monosaccharides, disaccharides, glucose, alpha and beta glucose, glycogen, starch, cellulose. Yep. The Benedict solution test, triglycerides, phospholipids. Okay, we've missed out some stuff. A condensation reaction between glycerol and a fatty acid forms an ester group, an ester bond, sorry. The R group of a fatty acid may be okay, we've done that. All we need to do is draw a circle and put ester. That's a little good bit of trivia to know, I guess, would be the gimmick here. A little bit of general trivia, which could easily come up in the exam, is just the different types of bonds. So, for example, a glycosidic bond would be between carbohydrates, your ester bonds between lipids. There are multiple bonds. There's a phosphodiester bond in nucleic acids. And then, obviously, your peptide bonds. So, that is that for this page. This is proteins and enzymes. Okay. Amino acids and monomers. Yep. Condensation reaction. The role of hydrogen, ionic, and disulfide bridges. I mean, we haven't really talked about the role of them. I mean, we obviously put ionic bonds formed between positive and negative charges. That's kind of it, really. Proteins have a variety of functions. I mean, I guess that's just kind of general stuff we should know. I don't really need to write that down. Just, they are used in hormones, enzymes, and a lot of other stuff. We did not talk about limiting factors for enzymes, but I have no bloody idea where to put this. I guess we'll draw a line here. Limiting factors for enzymes. You got temperature, pH, concentration of substrate, concentration of enzyme. So one of these is a bell curve. Well, two of these have a bell curve, and one of these, are just the flat lines. It's kind of hard to show. I'm on this section here. So that would be temperature. That would be pH. That would be concentration of enzyme. That would be concentration of substrate. Obviously, what we can put here for temperature and pH is kind of the same thing. It denatures the enzymes. And for the concentration of enzymes and substrates, we can kind of put the same thing as well. It increases up until there are no more, or until all active sites are occupied. Is that it? Please, for the love of everything, please. Are we done? Yes, I think we might be. Inhibitors, yes. Okay. There we go. We're halfway done. Christ, I am gonna cry. Okay. The digestion topic. I'm wondering whether I should even do that, because I did just do like 20 revision streams on it. And I'll be totally honest with you, I've forgotten a good majority of this already. So maybe it is worth my interest. Emulsion test for lipids we've done. Fuck. Semi-conservative replication. Shit, I forgot we needed to do that. And I don't remember what it is. I'm pretty sure that's where... Is it DNA helicase and DNA polymerase are involved? No, that's it. I think DNA helicase breaks the phosphodiester bond. No, it breaks the hydrogen bonds between the bases, which causes it to unzip. Then free-floating DNA bases bond with their complementary bases, giving you two pairs of DNA, maybe? I don't recall. That seems right. And then DNA polymerase would put the thing back together, put the bonds back together. I'm gonna need a catch-up on this. Semi-conservative replication. Yeah, I love all of these diagrams that make zero sense for the context of what I'm doing. Bro, I'm in year 12, I'm not like a fucking scientist, bro. Give me a normal definition. Okay, there. The DNA double helix unwinds and unzips because the hydrogen bonds break, yep. Okay, I think I got everything there. I just should have put that it involves... I'm just gonna check that there. Bro, my hands are messy as hell. The funny thing is, whenever I draw with white pen, I end up making my hands look all green and shit. I'm surprised I only covered a bit of my hand in pen. It's like I've been infected with something. Yeah, it involves ATP. Why did I write ATD? I'll just put replication. Okay. I'm gonna need to now step out of frame and take a photo of this. Jesus, my whiteboard is massive. There we go. Okay, I did that just because, like I said at the start, the teachers are now beginning to ask us to show proof of revision, and I can't really show them a 40-minute live stream of me talking, especially if I'm like swearing and stuff in it. So I'll just attach screenshots. But there we have it. I'm very happy with that. We've covered most of the topics in, I want to say, bare bones detail, because let's be honest, there is a lot of stuff that I haven't covered there that will likely come up. So you know what? Before we move on, let's do an exam quickly. And yes, that sounds so stupid. Let's willingly do an exam. No, let's do some exam questions dead quick. Like 2 minutes, maybe. There's a very good website that I use. And this allows me to revise a specific topic very quickly. A lot of these questions I have done though already. So this might just be me parroting the mark scheme. But here, biological molecules. Jesus, is my computer like having a heart attack or something? Okay. There is no specific topic, so let's just start with monomers and polymers. Describe the chemical reactions involved in the conversion of polymers to monomers. Oh, lovely. It's just condensation and hydrolysis. Give 2 named examples of polymers. So you would say, like, I guess, I don't know, things like I probably wouldn't put that. I would say maybe, oh, that is a weird one. How many marks? 5. Okay. That is a weird question. You would obviously refer to hydrolysis and condensation. I guess you would talk about amino acids joining together into, obviously, dipeptides, lipids with the whole fatty acids and glycerols forming ester bonds. That's a weird 5 marker. I've already done that question. What is a monomer? It is a small repeating subunit from which larger molecules are made. I guess would be the definition there. Let's check what the exam paper says there, because I don't wanna mess up there and end up having a wrong definition. That would not be good. A monomer is a small repeating unit or a molecule from which larger molecules are made. Yeah, okay. So instead of saying subunit, I guess it's just units. So a monomer is a smaller repeating unit from which larger molecules are made. Easy. And a polymer is a large unit made of many monomers, I guess. You know what? ATP, water, and inorganic ions. We could probably fly through these using a quiz. I don't even think I'll need to erase anything from the board. There is another good website which has a bunch of good questions on every biology topic. So what I'll do is I will go and do that now. So where is it? ATP. There is a single question paper here. So let's do that. 24 questions. We'll do this now. What is the immediate source of energy in a cell? That would be ATP. By what process do plant and animal cells release energy? They release it through respiration. ATP is formed of adenine, ribose, and 3 phosphates. ATP is adenosine triphosphate. Adenosine, I don't remember what adenosine is. I mean, thinking about it, triphosphate, so it obviously can't contain any phosphate groups. AMP, I don't even know what AMP is. Maybe 1 phosphate group. ADP is adenosine diphosphate, so that would be 2 phosphates. Where is the energy stored? It's in the bonds between the phosphate groups. They're very, what's the word? High energy, but easy to break. The energy is released via what type of reaction? That would be a hydrolysis. When energy is needed, ATP is broken down into ADP and an inorganic phosphate. What type of reaction resynthesizes? That would be condensation. What is the term used to describe the inorganic phosphate joining to other compounds and making them phosphorylation? So the inorganic phosphate joins to other compounds, making them more reactive. For example, the sodium-potassium pump, the inorganic phosphate joins to the pump to actually make it change shape. The name of the enzyme that converts ATP to ADP is ATP hydrolase. What are the products of ATP hydrolase? It would be the ADP, phosphate, and energy. Another name for the enzyme ATP hydrolase, ATPase. What type of reaction does ATPase catalyze? If it's joining it together, no, if it's breaking it, it will be hydrolysis. What is the name given to the enzyme that converts ADP? That would be ATP synthase. What does ATP synthase require for the formation? Probably the inorganic phosphate. Does it require energy? I'm going to put no. What type of reaction does ATP synthase catalyze? A condensation. Which of the following statements best explains why it's useful for storing energy? The bonds between the 3 phosphate groups, are highly unstable, and when broken, they release a big amount of energy. So the unstable bonds release energy. An immediate energy source is ATP. ATP is described because of the instability of the bonds. I don't think ATP can be stored in large quantities, but things like glycogen and starch definitely can. Which of the following processes is not powered by energy derived from ATP? Osmosis. Osmosis is a passive process. How many marks? It's 24. Please. 91%. There we go. Which ones did I get wrong? 13. Oh, I made a typo! Oh, that is stupid. I literally made a typo and that's why I got it wrong. Okay. As well as ADP, what does ATP synthase require? It does require energy. I did not know that. Okay. 91%. Let's quickly do the water quiz. And then that's all we're doing for today. What we will do tomorrow is some core math revision with Kieran. Wednesday, we will do some more biology revision. We'll move on to cell biology. And then we will move on to digestion and stuff like that on Thursday. Okay. Inorganic ions. How many is this? "20 questions. Okay. Which ions are components of DNA and ATP? That would be phosphate ions. Which ions have a role in pH? Hydrogen. Which ions are a component in hemoglobin? Ions. Sodium ions have a role in the transport of glucose. An ion is an atom with an electric charge, or more electrons or less electrons than usual. Which type of ion is positively charged? That would be a cation. And an anion is negatively charged. How would one describe an inorganic ion? It doesn't contain carbon. How is pH? It's the concentration of hydrogen ions, and it's log H plus, I believe. It's either log H plus or log H or minus log. Which ions form as part of chlorophyll? I don't know. I don't know. Genuine guess. I'll put magnesium. Which ion has a role in blood clot? Oh shit, I don't know this one either. I think it's either calcium or magnesium. Gonna put calcium. The absorption of light energy. Again, no idea. Which ion is associated with hemoglobin? That would be ion, or Fe2+. Which ion moves out of cells so that the mucus isn't thick? Potassium? Which ion is pumped into cells by active transport? That would be potassium. Which ion is used to produce amino acids and proteins? NO3. How will one best describe an organic ion? An ion containing carbon. Okay, genuinely, I don't think I've done that well there. A lot of those questions were guesswork. And my score is 85%, so I only got 3 wrong. What the fuck? The one I didn't get right was the hydrogen plus one. Calcium is what's used for muscle contraction, and chlorine is used in mucus. Did not know that. Cool. Alright, final one, water, the properties of water. This is 24. Okay. We got this. What is the incorrect description of water? It is a solute. A solvent is what's used to dissolve stuff in. A solute is what's being dissolved, right? Water molecules are slightly charged. I think the oxygen's negative, the hydrogen's positive. What is the example of a charged polar molecule that would dissolve? I'm going to say sugar. No, salt. Salt would not dissolve, sorry. Hydrophilic, so something that's hydrophilic likes water. sugar, maybe? Hydrophobic is water hating. Hydrogen bonds are weak. And hydrogen molecules can absorb a lot of energy. No idea what the specific heat capacity is. I'm going to put 420. What property does the high specific heat capacity? It means that the temperature doesn't change easily. The term used to describe that would be cohesion. No, adhesion. If water molecules stick together. What property leads to high surface tension? Probably the cohesion. Is water a good solvent? Why? Because it's polar, so it allows things to dissolve in it. Water molecules are made up of H2O. A water molecule is dipolar because the hydrogen is slightly positive. Which word is used to describe how they have both positive and negative? Dipolar. What type of bonds link water molecules? Hydrogen bonds. And the hydrogen bonds are very weak. Which of the following terms explains the fact it takes more energy to heat mass, a high heat capacity? During metabolic reactions, water is used to break down complex reactions. So water is a metabolite, and it breaks down molecules through hydrolysis. Cellulose is insoluble, right? So evaporation of water allows organisms to regulate temperature. The fact water is not easily compressed allows it to provide structural support to, I guess, earthworms. Which of the following is not a property of water? No idea. Okay. Finish quiz. I'm not expecting much here. 80%. Okay. Cohesion is when they stick together. Heat capacity of water is 4.2 joules. Gram minus 1. Okay. Which of the following is hydrophilic lipids? Oh, obviously, because they're both. And lipids don't dissolve in water. Oh, obviously. Alright then. Well, there you have it. I'm happy with that. 1 hour of revision right there. I'm very happy with that. Hope you guys are too. Not only did we revise the whole of the biological molecules topic, but we briefly covered some stuff which we'll go over next time as well. So yeah, I'm happy with that. Goodbye.